So a Leslie matrix is a transition matrix. So what we use transition matrix to explain how trends and things are going to happen in the future, or we see it changing. But it's used to, a Leslie is used purely to describe population changes. So when they collect data and they create these Leslie matrices, and you'll see that they're going to start using like a matrix like L. So you saw before when we use transition, they said a T, they'll use an L. Okay, now they'll explain that they only use female data because we're talking about population. Females are the only ones that reproduce, so they put that in there. That's just a thing. It's not a huge fact, but that's why. So what they do is they take up, they collect the data and they put populations into age groups. So, for example, you'll go 0 to 10, and the age groups are even. So you got 0 to 10, then 10 to 20, and then they just give it a number. So the first age group is 0 to 10 in this example here, and the second age group is 10 to 20, and so on. So what they will tell you and what information you will have in this Leslie matrix is that they will tell you the birth rate for each age group. Because if you're talking about certain species, it doesn't have to be human. It won't be human. It's generally, they're talking about animal species. You have that, the birth rates in different age groups of the animal. All right, so they'll call it, so they might say the birth rate for group 1 is so-and-so. So, it might be 1.2 per year. So that means that animal, in that age group have 1.2 babies a year and so on. So that's the birth rate. And they'll tell you what the time period is. Like I just called that a year, and they might say that. And then they say the survival rates of the population. So say moving from, the 0 to 10 year, moving to the next age category, you might have a 0.5 survival rate, which means 50% of that population survive to grow into the next population. So that's what this Leslie matrix is going to have. So they've got a little example there, like age group 2 might be 0.95, which means 95% of the 10 to 20-year-olds survive and progress to 20 to 30-year-olds. Okay, so as I said, they break up the age groups into even. So if you look here in this example, they're going in 3 years, yeah? And then they divide it up into 3 years. When you create your Leslie matrix, the Leslie matrix is always going to be square. And what do I mean by that? Same rows and columns. And it'll be how many age groups you've got. So because we have 3 age groups in this example, we have a 3 by 3 Leslie matrix. Now, across the top is going to be, they're going to tell you, or what we will record, the numbers in there are going to be the birth rate numbers. So the birth rate numbers will go into there. So say, for example, they said before, I'm just using it, maybe we have age group 2 might produce 3.2 babies per period. So that B2 will be 3.2. That will be the number that goes there. Okay, and then what we see is they'll tell you the survival rates, and the survival rates start under the first group, because obviously you're going to go from the first group to the next group. So that S1 there is the survival rate of the 0 to 3 group going into the 3 to 6 group. Okay, and you'll see then the survival rates go on the diagonal from underneath the first birth rate, and then go on the diagonal, and then that's it. So because you obviously only have, when we've got a 3 by 3, we can only have 2 survival rates. What about if I had a 4 by 4? How many survival rates am I going to have? 3. Good. So that's what you're going to see. So say we've got a little example here to help to show you. So they said, suppose the survival rates are 0.6 and 0.3. And then they said the birth rates are 0, 2.3, and 0.4. So can you see here, they've recorded those birth rates across there, and they've put the survival rates down there. What have they put in all the other spots? 0. And that's what you do. You put zeros everywhere else, okay? So zeros go everywhere else. The only place we're going to see data in a Leslie matrix is in those positions. Does that make sense? So just in the top row, which will be the birth rates, and then on that diagonal starting underneath the first one, and it'll be there. And sometimes, even then, one of the birth rates could be 0. So in this example, a birth rate was 0, which often makes sense in the first age group. You know, we won't see a lot of, think logically, we wouldn't see a lot of reproduction in such an infant animal. Okay? And then the survival rates and so on. Okay, so we can draw that information that we've been given in a trans life cycle transition diagram. So remember, with our transitions, remember we had the arrows and the circles? Well, we can do this with a Leslie cycle or transition matrix. So what you'll see is obviously here, here, these are what we would call, they're the age groups, okay? So if you want to, so you put the circles are the age groups. So say in that example before, I think 1 was 0 to 3, 2 was, and so on. Then you can see along in between those is, you can see they are the survival rates. So those arrows down there are the survival rates. So you knew, and it told you. So this would be survival rate 1. This would be survival rate 2. Okay? And then you have these red arrows up the top. They're the birth rates. So obviously you've got them going back, who produces. So if you have a look, this is birth rate 2. And that first one would be birth rate 1. Okay, so whatever the first category. So what they'll do is they will give you an SO. So that's just like in transition matrix. They're going to give you what originally is happening. So say, and then what you will find is how you get the next one. So here, just to show you, so SO, they're saying that's this one here. Okay, so what they did is they're saying 400, 400 like that. So this is age group 1, age group 2, sorry, wait a sec, and age group 3. So they'll say in the beginning, the 0 to 3-year-olds had 400 population, to 400 and 400, and then to get the next year, so next time period, we do the LO times the SO, and this would be after the end of the first time period of what's happened. Okay, so just change that to 2 and 3. Okay, all right, so how you get the next one, the next time period, so say this was a year. So they said this was what happened after 1 year. The birth rate for a year was so-and-so, and the survival rate. So in the beginning, we had 400 in each age group. After 1 year, we have a whole lot more in age group 1. So we've got a lot of infants. And then we can see we've got less in age group 2 and things. This is after 1 year. Now, you could get the next one. So you can see here, they take, so this is L1, and they put it down into here, and that's how they get L2. So you can get the next one by using the one before, or like in our transitions, if we want to go a little bit quicker, we can do that power trick, and we can always use SO and say here when we want S3, what they've done is they've done the Leslie matrix to the power of 3 times SO, and that gave it. So you can use the same thing as what I said in transition, that as long as this number and that number ends up being what you need, which is say L3, state 3, that's okay. All right, so it works the same way with that. You can either go step by step, or you could go quicker by doing the power. All right, so let's have a little look at this one. So they've done that. So you can see here, this is SO, really. This is S1, this is S2, this is S3, and you can see you would have had a matrix like that. So it helps us look at the population over time. And also, so you're breaking it up into categories, and you can also tally up and see what's happening. So you could, if you add them up, you get the total population. So this is, say, total population. Okay? Now, so we could see on a whole for this data, the population is increasing, isn't it? Yeah?
So in these ones...
Okay, so this is just summarizing what we just went through. So what they're telling you is that we are going to put all the age group birth rates across the top, and it depends on how many. This would be M equals, if you want to write a little note, M equals the number of age groups that you've got, yeah? So when we had 3 age groups, we only had a 3 by 3. If we've got 5 age groups, we're going to have a 5 by 5. That's what that means there. So we see the age, this is the birth rates going across the top. So we're just summarizing what we just said. And then we've got the survival rates going down there. So survival rates. Oh, sorry. Yeah, you know what I mean. Okay, so that's that little summary. If we go to this bit, we're talking about when we set the matrix up. So we'll have the, we put the birth rates across the top. So they're always going to have a 0 on the birth rate of the, because it's 0, you know, the first age category is always 0. So you can't, a newborn's not going to thing, so it's generally 0. And then we see the survival rates down there. Okay, and we see all the others are 0s. We then have, if we have to draw it in a diagram, so remember we've got survival rates going across here. So I'm trying to show you in the same colors so you can see. So you might want to highlight that, make your life easy when you're just doing this question in your exam. And then you've got your birth rates coming back like that. So they always go, note the birth rates always go back to the first circle, yeah? Because that, you know, you're producing a newborn. All right, so they're the birth rates. So that's that. The last thing is just it's summarizing what I said. If you have, you know, 5 age groups, you're going to have a 5 by 5. If you can always, maybe if you want to write a little note here, what that means, you can always get the next one, always get the next state by using the one before, or by using, well, the Leslie matrix times the state before. That's what that rule means, what they're saying there. Or we can, this is, if you just write a little note, this is like the power trick, using SO all the time, yeah? Okay, so we've got example 9. It says using Leslie matrix and initial state matrix below to answer the following questions from the age group. So question A is write down, so they're asking just you got to interpret. So they're seeing if you can interpret. Write down the birth rate for age group 2. So birth rates are up here in red. And what's age group 2? Birth rate is 1.8. Okay, so that was AI and AII. What is the survival rate for group 3? So survival rates are the blue. Here's the survival rates. What's the survival rate for group 3? 0.3. Yep, 0.3. So that's that answer. So for B, it says complete a life cycle diagram. So they don't call it a transition diagram, they call it a life cycle diagram for this Leslie matrix. So remember with your circles, you're going to have your age groups first. So draw them out. We've got 4 age groups. And I'm going to just do them in the colours that we've been doing. So we're trying to remember. So remember, the survival rates are between the circles, and remember they were in blue, so we're putting them across there. And then we are going to use, I'll use red to show the birth rates. So from 2 back to the start is 1.8, then from 3 back to the start is 2.6, and sorry, ran out of room, but all the way that last one, 4, is 0.1. So with question C, it says evaluate the following state matrices. So really what they want, if they want state 1, so the way we get a next state is we can use the Leslie matrix times the state before. So if it's S1 they want, we would use S0. So if you have a look, I've done them over here on the calculator, but you can just use the coding if you like. But here is and that ended up being, and that gives me S1. So you can do it like that. Now, because they said S1, I'm just going to use, and then, I'm sorry, I'm going to continue over here. When they wanted S5, I'm just going to use the power trick because I think that's the easiest. And I've already typed into my calculator pretty much all that information. So you can see here, I've done the Leslie to the power of 5 times the SO, and there I got the answer, and that one would be S5. Okay? And then they wanted S20. So we definitely wouldn't be doing it progressively with these ones. We're going to use the power trick. Okay? It would be there forever. And you can see I've done that one here. Leslie to the power of 20 times the SO equals S20. So just to help you make sure you're understanding, what was the original population of this data set? Yeah, 1,000 were bought, like in the beginning, yeah? So it could be like anything, research. They could be entering, say, like if you think, I don't know, fish in a tank at an aquarium, they chuck 1,000 babies into, a type of fish into the thing, and then they're going to see how these reproduce and the population grows, okay? So the last question, D, for this part, it said, given that the state, they gave you state 16, it says determine 17. So you have to use what they gave you. Don't go and use the original. Because the question is telling you to use that 16, you must use it. So what you're going to do, if you want to get state 17 and you've been given state 16, you're just going to do the Leslie matrix times the state 16. This is probably just this is one that they could give you where it's really checking that you're reading the question. Okay? So you must use what they gave you. Okay, so let's have a look at this one. It says information about a population of female goats is given in the following table. So you've got the age groups. So how many age groups have we got? If you look up how many age groups are we going to say? 1, 2, 3, 4, 5. Good. So that'll give us a heads up. Our Leslie matrix, the order will be a 5 by 5. Good. So the first question asks to write down the state matrix SO. So if we're looking at A, so remember SO is going to be a state matrix like this. We're going to have the 5 categories. And we're going to put how many, the original or the initial population. So my first number would be what? How many of the first group? 10, 25. Can you see I'm reading off that first row there? So this was, if you want to write, this is the SO matrix data. Okay? All right. B, it says, using this information, write down a Leslie matrix to describe the female goat population. So you remember, you're going to have a 5 by 5. So remember, you got birth rate 1, birth rate 2, birth rate 3, 4, and 5. And then you go down like that. So it's going to be a 5 by 5. So I'm going to do the birth rates in red. So 0, 0.2, 0.9, 0, and 0. Then I'm going to do my survival rates in blue. And remember, the first survival rate goes underneath that first birth rate. And then you're going to have zeros. And then you're on the leading, you're not on a leading diagonal, you're on the diagonal, sorry. Oh, it wasn't 0.2, what was it? Sorry, 0.6. 0.6, this one's 0.7, 0, 0, 0, and 0, 0, what was the next one? 0.5, yeah. And then 0, 0, 0, 0.2, and done. Mine's a bit messy, sorry. Okay, to keep going, C, they want me to construct a life cycle, so I need the 5 groups, age groups, in little circles across there. We put our survival rates along the bottom. And probably, like, if you're in the exam, if you've highlighted them like color coding, that might stop you doing like what I did before. You know, you accidentally read the wrong one. So, all right, and then we're going to do birth rates. So from the first group back, it was 0.2. From the third group back, 0.9. The fourth group, 0, and the fifth group. Yeah, well, I think either way they will take. Okay, so let's just do it to make sure we're, you know, deliberately knowing that it's 0. Okay. All right, and then the next one, D, it's asking us to determine the number of 3 to 4 year olds. So that's the fourth group of goats after in the population after 3 years. So that really means they want state 3. So you want state 3. Remember, you find that by going the Leslie to the power of 3 times the SO. And when you do that, oh, sorry, I'm going to run out of room. I have to write it small. It was 8.7, 10.17. No, after 3 years of the population. So, no, sorry. No. After 3 years, so just 1, 2, 3. 3 cycles, that's okay. 2.1 and 1.75. Yeah? So that ends up, and they only wanted in the question, what did they want? The 3 to 4 year olds, which was my fourth group. 1, 2, 3, 4. So here's where we might say, it says round your answer to the nearest whole number. So how many goats were in that age group after 3 years? 2. We're going to say 2 goats. Sorry, that does say 2.1. Okay, so let's look at this one. It says, consider the following Leslie matrix and the initial population SO. And it says to find S5. So this is AI. All you have to do is get that Leslie, put it to the power of 5 times SO, and what you'll end up with. So you might just want to write it down so you've got an example. So that would be S5. Okay, if I was finding S10, I would have done the Leslie to the power of 10 times SO, and that one equals 2,100. Okay, that's S10. So we're slowly going up in the states. So we could, and then S50, we're going to have a look. So we just do Leslie to the power of 50 times SO. So you do here, even in Leslie matrices and these population, you do hit a steady state. So if we're doing the power of 50, I'm going to say we've hit the steady state. We're not going to get any bigger. And we've got a lot of animals, whatever this is, whatever this population is. But you've got to remember too, these populations, it could be like bacteria growth, you know, so you can have big population. It doesn't mean it has to be an animal. All right, boys, that was that one. And then it says pre-multiply each of these state matrices. So once you've found them, they want you to pre-multiply it by this one. So pre-multiply means you take 1, 1, 1, and you're timesing it by this state matrix here. Okay? And what do you do? What happens when you do that? When you pre-multiply by a row matrix, what does it do? It adds up the column. So in this case, there's only one column. So what do you think it gives you? Good. So it equals, so I'm going to write it. Okay? And maybe write that in. That's the total population. And that's how they're going to ask you to calculate the total population in these matrices. In these style questions, they want you to show it via matrices. Okay, so this one ends up equaling, and the last one, so pre-multiply means you do it before. I'm not even going to write that one out. I can't be bothered writing that one. I'm just going to say it was S50. And that one equaled 3604272. Okay, so in part B, it says determine S25 and determine S26. So you can see, it's underneath. So you can see they've done that there. So we've done that here. And they've determined S26. Then it says divide each age group in S26 by the corresponding age group of S25. So when you did that, and you can see I've highlighted it. So when you did the first age group, so you did this first number, you divided it by that number, and then you did the same thing in the next age group. You'll find it was all the same number. It produced this 1.1915. So when they're producing the same, it's like the same rate of increase. Each age group is going up. So when that happens, we're saying that the population, they're all growing at the same rate because they are the same thing. And because we would say they're growing at 19%, whatever extra on one is they're growing. If they ended up being a number, if it's less than 1, they're all decreasing by the same amount, all right? So that's just an example. They might ask you, show that the whole population is growing. You just have to, and they'll tell you between here and here, you just do this and show it. Okay, limiting behaviours of Leslie matrices. Often we find that after a long enough time, the proportion of the population in each group does not change. So this is like the steady state. This happens if we find a real K, a number K, such that you find the next one is the same. And it's for a large number. So that means if we raise it to a high power, we are going to see that they do not change. But as it says there, it does not happen with every Leslie cycle. It could, but so if they ask you, find out what happens in the long run, just do it to a high power. If they're not, but we're saying it's not legit for everyone. So hopefully they'll say it doesn't happen and all that. Okay, so let's have a look at here. It says, consider the following Leslie matrix and the initial population. So, and it says determine S10, S14. So if we were doing this, S10 would be the Leslie matrix to the power of 10 times that SO. And when we do that, we get this. I'm going to pause the video and... Okay, so we've found all those ones. And now in B, it says the rate of increase of the population is constant. So it's like that before. When we divide them, we're going to see that it's the same amount. So it says find this rate by comparing S14 and S15. So what you're going to do is you're going to divide the categories. So you're going to divide that one by that and you get a number. Then you're going to divide this one by that number and then that number by that number, and you'll see that you get the same rate. So I'm going to show you here. Whoops. I'm going to do the first age group and I divide it by the S14. And what I find is I get 1.2. Now, if I did the second age group, so they told you that it happens, and I think this is what they're going to do in the exam. They'll say it is going to happen and you need to prove it. So you prove it by showing this. And you do it and you go, yeah, and that produces 1.2. And then you do the last one. So if all age groups are going up by the same rate, we can say that the population is increasing by that rate because they're all going up. Okay? Okay, in part C, it says confirm the ratio of the age group population stays constant for SO, S1 and S10. And that they're saying that it remains at this ratio, 8, 4, 1. So what they're saying there is that the initial age group is 8 times larger than the last age group 3, okay? And so what you can compare it, if you have a look, if we look at SO, it was 1600 to 800 to 200. Is that, if you have a look at that, is that 8 times, yeah? And this one is times 4, so that's in the same ratio. So this was SO. If I do the next one, if I do, what else did they say to compare? Maybe S1, which was 1920, 960, and 240. So this was group 1, group 2, group 3. This was S1. You can see it's the same ratio. This one is times 4, and that one is times 8 of that. So yes, that was the same. And then you can, if you have a look at S10, S10 does the same with some large numbers. And that's all they're doing. So if they just say compare, you just show it like that. As I said, oh God, I can't fit that one in. So this one also would be, it would be 8, 4, 1. All right, consider the following Leslie matrix and the initial population. Now, it says investigate the long-term behaviour if the population, if B3. So what they're doing is they're changing the birth rate in every scenario. So B3 is that number there. So when they do this first example here, and they found, and they show you they found S1, S2, and S3, the Leslie matrix that they used here was they put an 8 there. All right, so that's what that question's saying. So they've done that where they've put an 8 there, and they've calculated, they've done this calculation. So you can see that when they did that, you started off with 1,000, then you had 250 in the second age group, then in the second year you had 125 in the last age group, in the third year you were back to 1,000. So they might just say to do these, and then they'll say comment on it. That means after 3 cycles, the population is going back to its initial amount. Okay, so after 3 cycles, it goes back. When they do the B4, so they're just changing that number, like that's the number we're changing in there. Okay, so they created a Leslie matrix, and they put 4 up there in birth rate, and they kept everything the same, and they asked you what happened then when you did that. So you looked at 1, 2, no they didn't. They looked at, they just looked at the cycle, and they just went L1, L5 and L50, and then they just said it decreases after a while. And then they did the last one, they changed it. They said have a look when you do B10, and we had a look at S1, S5 and S50, and we saw that that one increased after a while. So don't worry, just they'll bear with you. They'll tell you what to do, calculate this, what's happening to the population, and you just explain it. All right.